Hello, algebra students, and welcome to another lesson in Chapter 6. Today we are talking about linear inequalities. So remember, the word linear just means line, and inequality meaning that they are not going to be equal. What I'd like for you to be able to do by the end of the class is to solve linear inequalities that have two variables, in other words, x and y. So what is a linear inequality? A linear inequality in two variables, such as y is greater than x minus 3, can be formed by replacing the equal sign in a linear equation with an inequality symbol. So this equation right here, or this inequality right here, works very, very similar to y equals x minus 3. Now we just have an inequality symbol in there instead of the equal sign. Now, because there's an inequality, that means that we're going to have lots of answers or solutions. So the solution of an inequality in two variables is any ordered pair that makes the inequality true. So let's look at just an example of that where we plug some numbers in and see what it does. It says, is the ordered pair a solution of y is greater than x minus 3? So what we're going to do, we're going to take our values and substitute them into this inequality. Y is 2 and x is 1, because remember, when we have an ordered pair, it goes xy. So let's substitute those values in. I am going to have 2 is greater than 1 minus 3. That reduces to 2 is greater than negative 2. Is that true? Yes, it is true. So that means, yes, that is a solution to that inequality. Let's do that again. So we have x and y. Now we're plugging in negative 7 for y. So I have negative 7 is greater than negative 3 minus 3. That reduces to negative 7 is greater than negative 6. Is that true? No, it is not. So no. So that means this one is not a solution. But we could ask ourselves, what's another solution? Can we come up with something? Well, what if you put 0 in? So if I had 0 is greater than, what's something that 0 would need to be greater than? 0 would need to be greater than negative 1 or negative 2. So what if I put 0 in for x? This would be 0 is greater than negative 3. Yes, that is true. So another possible solution is 0, 0. Now, there's an infinite amount of answers to this, because there are tons and tons of ordered pairs that are going to make this true, right? We could say 100 is greater than 3 minus 3. So that's another ordered pair that works. So this could just go on and on and on. So now, how are we going to graph these? So first of all, you're going to graph the boundary line of the inequality. This works the same as the way you would graph an equation. So graph with the same strategy as y equals mx plus b. So you're going to start with your y-intercept and use your slope from there. We're not changing that. The difference now is decide whether it is dashed or solid. That's something new, dashed or solid. What does that mean? Well, remember when we have just a plain number line? And if it is less than or equal to or greater than or equal to, we color in the circle. But if it's only less than or greater than, then we leave the circle open. Well, what about when we are graphing this as a line? What are we going to do then? Well, if we have greater than or equal to or less than or equal to, it's going to be a solid line like this. But if you have strictly less than or strictly greater than, it's going to be sort of a dashed line like that. So dashed is when there's no line underneath, and a solid line is when there is a line underneath your inequality. So that's the first part. Now also remember, when we were graphing on a number line, we had to shade in a certain direction. So maybe this would be shaded that direction, and maybe this one would be shaded in that direction. I'm just making that up just so you can see what I mean. So how are we going to account for the shading now? Well, the easiest way to figure out where to shade on a graph is to test an easy point. And the easiest point is the origin. You can just use 0, 0 every time. So when you test that point, if it is true, then you shade on the side with 0, 0. But if it is false, then you shade on the other side. And you're going to see what I mean by that here in a minute. Let's just do a couple examples, and I think you're going to catch on. So it says, graph each inequality. Cool, let's do that. This is y is greater than x minus 2. Okay, I want to graph this using my strategy of y equals mx plus b. So what is the b? It's negative 2. So I go down 2 on my y-intercept and put 1 there. What's my m? Well, the invisible number in front of x is 1. So that means I go up 1 over 1, up 1 over 1. I'm going to keep doing that just so I have a decent line for where to go. Then I want to determine, is this line going to be solid or dashed? Look at your inequality. Because there is no line underneath it, over here there is a line underneath it, but there is no line underneath this one. That means this is going to be dashed. And just do your best on that part. I know it's not going to be the most beautiful thing in the world. Now I need to figure out shading. Well, where am I going to shade? I'm going to test 0, 0. So I'm going to plug those into my equation. Is 0 greater than 0 minus 2? Is 0 greater than negative 2? Yes, it is. So that means this point right here, the origin is a solution. So everything on that side is also going to be a solution. So I'm going to shade that part of the graph. Okay, let's do that again just so you can see it again. So let's graph this one. I have y is less than or equal to negative 3/4 x plus 1. I'm still using y equals mx plus b. So I go to the 1 on the y-axis, and that's my y-intercept. Then I have a slope of negative 3/4. So I go down 3, 1, 2, 3, and then I go right 4, 1, 2, 3, 4. I'm going to run out of space, so I go back here, and now I go up 3, 1, 2, 3, and left 4, 1, 2, 3, 4. Okay, I have my boundary part, some points. Now I'm going to look right here. Is it a solid or is it dashed? It is going to be a solid line. So now I'm just going to connect these as best as I can. And finally, I need to test 0, 0. So if I put 0 in for y, is 0 less than or equal to negative 3/4 times 0 plus 1? Well, what is negative 3/4 times 0? Anything times 0 is 0. So now I have 0 is less than or equal to 0 plus 1. 0 is less than or equal to 1. Yes, that is true. 0 is less than 1. So that means anything on the same side of the line as the origin is a solution. So now, now the answers are all below the line. Okay, keep going. Let's try this equation, or inequality, I should say. I want to start with the 1, so I'm going to go up 1 on the y-axis, and then I have a slope of 1/2, so that's up 1 over 2, up 1 over 2. Notice a positive slope is going uphill. Then I look right here, because there's a line underneath, that means it is a solid line. So I connect them. And all of that you've already done. The new part is figuring out where to shade. So I'm going to test my point 0, 0. I'm going to have 0 is greater than or equal to 1/2 times 0 plus 1. 0 is greater than or equal to 0 plus 1. 0 is greater than or equal to 1. Okay, ask yourself, is 0 greater than or equal to 1? No. No, it is not. So right here is where that solution is that I just tested. I tested, is the coordinate 0, 0 an answer? No, it is not. So that means the bottom of the graph is not the solution. The top of the graph is. My answers are going to be above the line or on the opposite side of the origin. Okay, we have one more inequality to graph. We have y is less than negative 2x plus 3. I'm going to go up to the 3. That's my y-intercept. And then I have my slope of negative 2, so down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And I can fill that in all the way. Then I look at my inequality. This is going to be a dashed line because there's no line underneath. So I'm just going to kind of dash it as best as I can. Okay. And now I need to figure out where my shading will be. So I'm going to check the point 0, 0. Is 0 less than negative 2 times 0 plus 3? Okay, is 0 less than 0 plus 3? Or is 0 less than 3? Yes, 0 is less than 3. So the side that the origin is on right here, that is the side where all of the answers are on. So now I shade that side of the graph, and I'm done. All right, that's it for today's lesson. I hope that it's making sense for you, and I look forward to seeing you in class tomorrow. Bye.